Hey everybody!
Why, hello!
Mr. Sharky and Mrs. Cat here with another exciting chemistry video.
We're gonna do a little solubility and solutions lab here. So we've got 4 different parts. We're gonna be looking at all of these different variables that have an effect on solubility.
To walk you through a bit of the setup, we've already weighed out the appropriate amounts of salt for all the different parts. So we've got 0.25 grams kind of set up throughout the table. In the lab, we'll be looking at a couple different kinds, so let us just show you those at the top. We've got some larger salt crystals, some medium-sized salt crystals, and then some small salt crystals.
These are all just sodium chloride, so what you know as salt. So the chemical makeup is the same, but the size of the crystal is different.
We've got a couple different things going on, so we'll just walk you through. In part 1, we're going to look at different temperatures of the water, see how that affects solubility. So I've got a beaker warming up, got one in an ice bath that's kind of tucked away, and then we have some at room temperature. We're going to look at the various salt sizes, or the sizes of the crystals, and then we're also going to look at agitation, so stirring versus not stirring. And then we'll do a 4th part that's a little bit different. Yeah, let's go ahead and get started. Wow, let's get started with part 1.
That's where we started.
That's the best place to start, always and forever.
So we're gonna look at the effect of temperature on solubility rate. So we've got samples of salt already measured out. We've got 0.25 grams. We've got just a normal size salt crystal, kind of in the medium size of the 3 that we have. But what we do have are 3 different temperatures of water. So Mr. Sharky just pulled off some water that has been heating up on a hot plate. I hope that you can tell that there is some condensation around the top of the beaker, showing you that some of it has started to evaporate. Right here in the middle, we've got room temperature water that just came straight from the faucet. And then in our 3rd beaker here, we have some water that came from an ice bath. You have a beaker that's in the sink that's got a mix of ice and water. So that's gonna be cooled down. You're gonna have to take our word for it that these are at different temperatures.
Sure. I'm gonna go ahead and get my stopwatch going. In this section, we are going to just dump our salt in. And are we supposed to stir? I think we do stir in this one.
We are going to stir these.
So we're going to stir them just to try to stir evenly. Make sure I'm not giving any more sauce to one or the other. Try to have an equal amount of stirring to keep as many variables the same as possible. But also, hopefully, stirring will help speed the process up a bit.
So
maybe we'll investigate that later.
Yeah, and I just realized we don't have a thermometer to take our actual temperatures, so we're gonna estimate here that this one's about at 95 degrees Celsius.
Yeah,
we're gonna call this one about 25 degrees Celsius because it is a little warm in the classroom today, and then we'll call this one
like probably about,
what do you think?
15?
15? Okay, so those are our 3 different temperatures of water.
All right, so
all right, I'm ready.
We're gonna go ahead and dump in our hot, and I'm gonna start stirring. You got our timer ready?
I'm going.
And while we're stirring, I am looking at the bottom and sides to see when all of the salt has disappeared.
It's getting close to gone. You got a better angle than I do.
Yeah, I am not seeing any more.
I don't see any more.
I think that's it. Let's call
it.
it.
24 seconds.
Woo! Only 24 seconds for that hot
All right.
beaker. We're gonna go ahead, dump the same amount of salt.
Exact same.
Into our room temperature water.
Okay, I'm ready.
You ready for me?
Yep.
Dump that in, and then I'm gonna start stirring. Again, trying to keep as much similarity as possible. So I'll stir with about the same speed.
Which is why I am not taking over the stirring duties. We're gonna keep that a consistent variable here.
That's looking pretty much done.
Boom, 147.
147.
All right, this was 147.
At this point, hopefully you are recognizing some sort of trend, but we are going to go ahead and do our cold water. I had to use a smaller beaker so we could actually get the ice bath thrown together, but it's still got about the same amount of water, same amount of salt. We're just gonna go ahead and dump this in, and I'm gonna start stirring and hopefully not splash too much.
That's all right.
Okay,
Oh, I think that's it.
looking pretty good. I'll call it
326.
326, and my arm's not sore at all. Actually, is what's crazy.
All right. Cool. That's
part one.
part one, temperature and solubility rate.
Start working on those claims, evidence, and reasonings.
Based on our data. Get those data points
We'll be
recorded.
back in a second with part two, which we're just about to film.
Let's do it. Where are we gonna start, Mr. Sharkey?
Well, now we're back with part two.
Part
because
two.
we already did part
That's
one
right.
earlier in the
So,
video.
part two, we're gonna look at whether or not stirring has an effect on the rate of solubility. So, Mr. Sharkey is going to be the stirrer. I'm going to be the non-stirrer. We both have equal amounts of the same size salt crystals, which is 0.25 grams. And we're gonna put this in our room temperature water. So the amount of salt is the same, the amount of water is the same, and the only difference is gonna be Sharky's gonna stir, I'm not.
We're gonna go until we can't see crystals anymore. So Mrs. Kat's got her own stopwatch to keep track of her time. I've got mine to keep track of mine.
Okay.
We're just gonna try to knock both of these out.
Ready?
So go.
Okay.
And I will be stirring the
I
entire
get the
time
easy job.
until I can't see any more salt. Feel free to sit back and relax.
Yeah.
Enjoy the ASMR of glass lightly scratching glass.
And salt hanging out in a beaker of water. It's just hanging out there. Really exciting. Now, I do have my data sheet here because we are going to be
Okay.
recording our data so we can help you out at home to record those data points.
Me,
I
that
think
looks
that's all
pretty much
gone. Where are we
done.
at time-wise?
That puts us at 1 minute, 31 seconds,
All right.
31 milliseconds.
131.31. Nice little palindrome. Well, I saw a lot going on in mine. I'm at one, obviously, still going, 145. We're just gonna like keep this one going. We're gonna set this off to the side so that we can come back to it later because I'm getting bored waiting. So I'm gonna move this off. We'll come back to this and see how long it takes. I'll keep the timer going. We'll let you know. Okay, so we're back to wrap up part three.
Part
And,
2.
Oh, part two.
We gotta wrap up part 2.
Part two. We
Start
can't
part
do
2.
part three without wrapping up part two. So we've got a beaker here that is my no stirring room temperature beaker. And this guy took us 8 minutes and 27 seconds to dissolve all of that salt just hanging out. So compared to our 1 minute and 31 seconds with our stirring. So give you a little bit of data there to use for your claim evidence reasoning with the effect of stirring or agitation on solubility rate.
Wow, part 2 was exciting. But,
Sure was.
But I bet you can't wait for part 3.
I know.
One of the best parts
It
of all.
is. It is.
What we're gonna do here is we're gonna take our 3 different sized salt granules and we're gonna see how each of them dissolve. So we've got our very small, finely powdered salt.
Super small.
We've got our normal grain that we've been using for all of the others.
Probably like what you would use as table salt.
And then we got some chunky salt, some larger crystals that are a lot more visible to the
Yeah.
naked eye.
These are all the same mass. So these are 0.25 grams of salt. The only difference this time for us is going to be the size of the crystals. We've got the same volume of water, same temperature of water, same mass of salt.
Yep.
So we're going to take a look at these. We're going to stir these this time around. I'm going to take over stirring duty since Mr. Sharkey did the heavy lifting on part one with all that stirring, especially me on that cold water one.
All right.
How we want to go? We want to go small to large?
Let's go small to large, because that's how our data table is set up.
Perfect.
So Mrs. Cat's gonna start off with the smallest powder, and
you
let me know when you're good.
Okay, here we go.
And our timer is running.
Do you see any more?
I do not see it.
I do not. That's it.
That's probably it. All right, that was 22.93 seconds.
All right, 22.93. Record that data. All right.
All right.
Second up. Now I'm going to continue to stir as we're going to keep that variable consistent here. I'm going to try my very best to make sure that I'm stirring in the same manner, same amount of force here. So there's our medium-sized crystals, and here we go.
Going.
And it's gone. That's it.
That's
where we at.
11.25 seconds.
Okay. 11.25. Okay.
And our final setup with our salts.
This is our large crystals this time. Are you ready?
Yep, when you are.
Now, I'm noticing immediately that there's only like 5 crystals, maybe 5 or 6. Mm-hmm. One is particularly large, so we're gonna have to maybe see what happens with this large crystal. Now, it is getting smaller. Or Big C? It started out as Big C. We are getting
a little bit of a Benjamin Button situation.
Are you sure you don't want to time lapse this?
No, I think the live video with the bell is actually ideal.
Oh wait, where'd little C go? Big C.
And much like Houdini, little C is gone. That puts us at 2 minutes 41.7 seconds.
Oh my gosh. Oh, okay, we got it.
All right, everybody. Thanks for tuning in to part 3.
Catch us later for part 4.
Part
Liquid
4 is
solutions.
pretty crazy. Thanks, everybody. Oh, man.
Time's up.
Oh, wow. Part 3 was wild. I didn't believe the results.
It was insane.
It was so good.
So we're going to switch it up. No salt this time. We're going to look at a couple liquid solutions. What we've got are some plastic test tubes with some metal caps. We've got about 2 milliliters of water in each test tube. We're going to add 2 different solutions and kind of see what happens. So,
you want to talk about your
yeah, I'm going to
first?
start with hexane. I guess just turn this around. This is an organic molecule that I'm going to add in here. I've got a pipette that I'm going to use, and I'm going to add 10 drops of the hexane in here. 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, whoa, getting a little crazy. It's a volatile liquid here. So, what I'm noticing here, and I'm gonna I'll make sure that to let you get in and zoom this in, but I can see a little layer of separation between the water and the hexane. I'm gonna add 10 more drops, and we'll see what happens here. 1, 2, 3, 4, 5, 6. 7, 8, 9, 10. Give it a second, and I still see the same thing. Now, what actually I'm noticing is that I can kind of see 2 menisci.
Menisci?
Yeah. One is convex and the other is concave, but there's definitely separation here between the 2.
Going on.
Something happening. All right,
If you want
what do you
to,
got?
while I measure mine, you could put a cap on, mix it up, and see what happens.
That.
I've got
Great
another
idea.
10 milliliters of water, and then I have ethanol. You all may be familiar from your work in Unit 6 with this OH that kept showing up on a bunch of our Lewis structures. That is actually what...
Unit 7.
Unit 7. Oh,
and the OH that we were naming, that hydroxide.
That
in Unit 6.
hydroxide shows up
keeps
a
popping
lot.
up.
That's an alcohol. Ethanol is another one of these alcohols, similar to like rubbing alcohol or something like that. And what I'm gonna do, I have a dropper bottle, I'm just gonna add 10 drops as well. We're gonna see what happens. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I've got 10 drops in here. And what I'm noticing, and I'll hold it, I do not see 2 layers. It looks like my liquids have almost merged inside.
Yeah.
I don't see a clear separation like we did with the hexane. So
Add some more and see what happens.
let's add some more, see what happens. I'm gonna add 10 more drops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And again, as soon as they're added in there, I cannot see a difference. I'll add a cap and I'll shake it up.
And then let's check in on our hexane after I've shaken it up and let it sit. It's still got the same situation going on. We've still got 2 layers in the water and cyclohexane test tube.
My
what do you got
ethanol,
going on?
I noticed that it bubbled for a second and then it's kind of gone back to normal. It just looks like one substance throughout.
Yeah.
So go ahead and make some observations about those, compare and contrast.
That'll wrap us up for
That's
our
it.
Solubility and Solutions Lab. So,
Sad to see you all go,
but
be
don't
sure
worry, we'll do that.
Make sure to like and subscribe so that you're notified when we're uploading a new chemistry video.
Great.
Bye everyone.
Oh, we're such dweebs. I love it.